Welcome to today's webinar with the title You Have the Choice, RIGID.flex with Flexible Solder Mask or Coverlay. I am Andreas Schilp, your host of today's Würth Elektronik Circuit Board Technology webinar, and I would like to welcome you. The speaker in today's webinar is a qualified specialist from Würth Elektronik Circuit Board Technology, Werner Oechslen from our Technical Project Management. Welcome back, Werner. And now I wish you lots of fun and new information.
Okay, thank you, Andreas, and hello and welcome also from my side. Today we speak about a real interesting topic. It's concerning solder mask or coverlay. So we always get questions, what is better for which application? In the following slides, we will see the agenda as here. But first, I would like to introduce myself. My name is Werner Oechslen and I'm working here in the Technical Project Management at Würth Elektronik now since more than 20 years. So my focus from our department is that we are getting, I would say, special customer requirements which are, I would say, above our standard PCBs. Yeah, mainly flex rigid printed circuit boards, and me and also my colleagues would be happy if we could help you. Okay, so today I would like to speak about flexible solder mask, coverlay. So first a small introduction. What is a flexible board, flex rigid board? Then I come to the second point. It's concerning the coverlay itself. So what is a coverlay and what are the properties of this material? Then I will show you a little bit about the application and the production, how is the coverlay handled and so on, and some points regarding the design which you must consider if you are designing a board with a coverlay. On the other side, we have the Flexmask, flexible solder mask, or named Covercoat. The same here, the properties, introduction, the applications, and also at the end something about the design. Yeah. At the end, I would like to compare both. So what are the advantages for which application, so that you can see for which application which is more helpful for you to get at the end a real good working product. Okay, we start directly. Why using a flexible circuit? Yeah, you could see on the right side the different points here, like miniaturization, reliability, signal integrity, dynamical bending, or system benefits. Always, I would say always, if one of these points fits, it makes sense to think about using a flex rigid board, yeah, to get a three-dimensional PCB. As you all know, I think you all know the flex rigid itself. There are a lot of variety of possible materials and material combinations. So yeah, flex outer layer, flex inner layer, then 1 layer, 2 layer, 4 layer, 6 layer, 8 layer, 10 layer on the flex part. So in this webinar, I would like to give you a little overview when we use flexible solder mask and when a coverlay should be used. So what are the base functions? So the main base function is the encapsulation of the conductors to protect against the corrosion and oxidation, so that the lines in the flexible parts are covered by a coating. Yeah? And also the protection against environmental things, and what should also be given at the end, the bendability. On the one side we have flex to install applications, 1-time bended, 10-time or 100-time bended, or on the other side dynamical bendings, where we have millions of bending cycles. There we have to consider also a little bit more than, I would say, only using a flex mask or a coverlay. So in this picture here, you could see in this part here, mainly we are always we are doing on the rigid parts, we are using a standard solder mask. I can open this standard solder mask for the SMD components, for the assembly and so on. Here is the flex rigid intersection. Flex rigid intersection is here, and here begins the flex area, and you can see here by the brown color, this is the Coverlay itself. On the other side, you could see also other applications. So here in this case, it's always a bundle application. Today, I only would like to speak about Coverlay in the flexible area for covering, because we also have other applications with Coverlay. Like you can see here, it's also a possibility that a Coverlay could cover also rigid bars, so that we could overlap vias and so on as an insulation. Maybe if you put it directly in a housing by a screw or something else, that it's because of insulation. But there we also have an older webinar where you could have a look inside. Yeah. So we will today only speak about Flexmask or Coverlay in the flexible region. What is a Coverlay at the end? Coverlay is also is a material laminated by two materials. On the one side, the polyimide material, which has a thickness of 12.5, 25, 50 micron, 75 micron, 100 micron. So it depends on your application you have. So our standard polyimide thickness, if you don't have any specification, we are using a 25 micron thick polyimide foil. Then we also have under this polyimide foil an adhesive. This adhesive thickness varies from 25 to 50 micron. Also, it could be an acrylic or an epoxy adhesive. So it's always depending, I would say, on the copper thickness, which we have to cover by this Coverlay. Here you could see a slide of this Coverlay. You could see here the brown color. Brown color here, it's the polyimide foil, and the white color, it's the adhesive itself. You can also see it in some applications. Sometimes the Coverlay looks, I would say, it looks more brown, I would say, and a little bit more yellow. Yeah, this depends only. There's a different polyimide thickness. Yeah, so here you could see more the white glue in behind, and the thicker the Coverlay, the more, I would say, black it gets. So what are the characteristics of such a Coverlay? So these are available also as flame retardant VO material with a thermal conductivity of 0.2. So this is interesting. So it's better than air. So if you want to have your PCB directly to a metal housing or something else, and you could have this Coverlay there in between. So there's also I would say a nearly good, I would say, thermal conductivity. What is perfect for this material? It's the dielectric strength with 4 kilovolts per mil. So 25 micron has 4000 volts dielectric strength. And also a real good advantage of this Coverlay material is the low outgassing. So if you have a vacuum application, so it makes more sense to use a Coverlay instead of a solder mask. Types, prototypes of Coverlays. So we are always using Coverlay only partial in the flexible area, which overlaps at the end in the rigid area. So like we are producing this, comes on the next slide. You could see here on the right pictures. On the one side, the flex in the inner layer. You could see here the cover foil, Coverlay, which covers the flexible area, and the overlapping is roughly 1 millimeter into the rigid parts. The same here with a 2-layer flex outside. So we always, if we have a depth milling anywhere, we must use a cover foil. On the outer layer, I will come later to it, we could also use a flexible solder mask. Why? So why only partial? So it would be much easier if we would cover all the PCB by this cover foil. So this Coverlay has no good, I would say, thermal properties. So it has real high CTE, so real high ZX expansion. So what we want to have, we don't want to have any Coverlay foil, any polyamide acrylic glue in the drillings of the PCB. So with this partial Coverlay, your flex rigid board is much more reliable. So, and we as Würth Elektronik, we are only producing flex rigid boards with this partial Coverlay or bikini technology. Okay, allocation, it's possible in the inner layer and also on the outer layer. Now I will show you a process flow of such a typical flex inner layer. So it's now a 3RI, 2F, 3RI board, as you can see here. We have the rigid cores, which are here structured. We have the pre-bricks, which must be milled for a flex rigid board. And we have here now the flex layer, so the flex base material with copper, where we have the inner layer processing, the etching, automatical optical inspection, and then we have here the Coverlay fixation and the Coverlay pressing of this Coverlay film. So here to this part we'll go on the next slide also a little bit deeper. So after this Coverlay lamination, we come again to the multi-layer pressing, where we at the end press the total, I would say, flex rigid board. But how is this Coverlay done to the flex inner layer? So what we are in general doing, we are cutting this Coverlay by a knife, or we are cutting it, or we are doing a laser cutting process. You could see here on the sheet, we have now a lot of small, I will say, parts. The next step is the registration. So we have here under, you could see here, the flexible inner layer, and we are putting here a mask on it with openings where at the end the flexible area is. And then we are doing it like a puzzle. We're putting the parts here inside, and then we are fixing this at the outer points by a solder joint. And the last process step, we are going to a vacuum pressing, and we are pressing this Coverlay on it. And after this flex inner layer is finished, and afterwards this, I would say, second lamination process or pressing process takes place where we are putting the rigid materials on top and bottom of the PCB. So as you can see, if we have a Coverlay foil, we always have a cutting process, we have a manual, I would say, puzzle process, we have the fixation process, and we have an additional pressing process. So a lot of manual workload which is needed. So it always depends, do I have real small parts or do I have real big flexible parts? So this depends on, at the end, the costs, how long it takes for the handling of this material. So this is now the Coverlay part. Now we come to the Flexmask or Covercoat. So what is this Covercoat? So it's a lack of unfilled polymers, polymer mixtures, epoxies, pigments, solvents, and at the end we want to protect also the conductors, but this is then also only possible on the outer layers with a flexible solder mask. The characteristics are the same: flame retardant, low expansion, high surface adhesion, good thermal stability. So, and we have two different types of coatings. We have on one side a photo-imaginable flex mask, and on the other side a non-photo-imaged solder mask. So it's a little bit more or better in costs, I would say. So what are the types, properties, how we are doing this on the PCB at the end? We have on the left side this photo image cover coat. It's applied by, on the one side, a screen printing or a spray coating, and only used for outer layer, and the position accuracy is plus minus 50 microns. So it's perfect if in this case, I could also put the flexible solder mask over the rigid parts. So I don't need an extra second luck for covering the rigid parts. With this non-photo image cover coat, we are only putting this flexible solder mask in the flex area by a little overlapping to the rigid area. And you can see the accuracy is a little bit higher, so plus minus 200 micron. So, how is it done? The application, so we have on the one side for this, I would say, for this partial cover coat, we are doing this by an inkjet process. That means we have the finished outer layer etched. We are putting our standard solder mask on the rigid parts, and we only have now 3 flexible areas. Then we are doing once again a pre-cleaning, then we are doing the inkjet printing of the flex mask, we're doing a UV curing, and at the end a thermal curing where the mask is burned in at the end. If I have a screen printing, I always need a screen, which costs already a lot of money. I need a pre-cleaning, then also screen printing process itself, the thermal curing, and I have to wash the screen, or I need for the next batch a new one. Yeah? So there are a lot of costs. So our standard process in our, I would say, series plant is that we are using a non-photosynthetic cover coat. That means this is only placed on the flexible area. I'll show you here now 2 cross sections, how this looks like. So you could see here the polyamide material itself. You could see here this polyamide exists of 2 polyamides with a glue in between. In this case, we have here the copper lines which are running over the flex area, and here the flexible solder mask which is covering the layers. Here you could see now a cross section of the intersection. So this part here is the flexible area, and here now is the rigid area. You could see here the rigid solder mask and the flexible solder mask, which is overlapping in a small area, I would say, on the rigid solder mask. What we don't want to have, that we have any missing solder mask here, that we get a surface or something else on the conductors, that we get free conductors in this area. Okay, how is this done? I have here a small video. So you could see here our production panel where we are producing this flexible flex rigid boards with. You could see here the standard solder masks is already placed on the panel, and you could see here the small areas. There's currently the flexible areas which should be covered by this inkjet process. I'll now start this video. 1 second. Okay, so on the vacuum desk, then we are cleaning once again the whole panel. Then we are starting the machine. Goes inside into the inkjet printer. Now we are searching for the registration of the layout. And then this printing, inkjet printing itself takes place. I will go a little bit further on because it takes 1 minute, I will say. Afterwards, the panel comes out. And here you could see now the rigid areas covered by the rigid solder mask and the flexible areas which are covered by the flexible solder mask at the end. If you would see now, if we want to do this by a Coverlay, it would have a lot of effort, a lot of manual effort. So in this case, yeah, it would cost much more in a Coverlay variant than in a flexible solder mask variant. Okay. Now we come to the application in our portfolio. So I have now our 4 main technologies for flex rigid. I have the 1F XRI technology here now on the left side. 1 second. Exactly here, 1F XRI means 1 flexible layer on the outside. So we could use here a Covercoat or a Coverlay on the outer layer. If you don't have any specification for us, you are ordering a PCB at us, our standard is always a Covercoat or Flexmask for the outer layer. If I have now the Flex Rigid 2-layer flex outside, I always have here on the outer layer, I could choose a Flexmask or a Coverlay. On the inner layer, I always have to use a cover foil for it. So this is not possible by this inkjet process and so on. If the flex is in the middle, we have seen already before, only Coverlay is possible. And if I have pure flex PCBs or pure flex with a stiffener, I could use a Covercoat or a cover foil on it. This depends also on the layout you have, because with a Coverlay I need bigger clearances and so on to SMD pads because of registration and also the resin flow of when you do the pressing process. So what is now the summary, the comparison? So Flexmask, non-photosensitive, so it's the standard at Würth Elektronik. The main advantages here are the costs, and we have small flexible areas are possible. The disadvantage here, it's only partial in the flexible area, so we always have two coating systems, so one on the rigid part and one on the flexible part. This photosensitive Flexmask, also the advantage is the costs. We have one coating system, also small flex areas possible, and disadvantage is that no thick copper is possible, so e.g. 70 micron copper are not possible by the system. And we are only using this flexible photosensitive Flexmask in our prototype plan. So if we have series products, we're always using this non-photosensitive Flexmask. On the other side, we have the Coverlay. So what are the advantages? So you have different thicknesses in glues and polyamide thicknesses, which fits at the end perfect to your application. Then the Coverlay could also be used as an isolation. So if maybe if a housing, a metallic thing is real near to the flex area, so the Coverlay is then at the end the isolation. Or the next thing is a dynamical bending. If we have also thousands of bending cycles, we would also recommend to using a Coverlay. So this foil in a dynamic bending bends much more reliable. We have abrasion resistance, which is much better than with a Flexmask. And also one big point at Coverlay is you always get the same in the market. That means, as you have heard already, we are already using two different Flexmask types. So if you are ordering a Coverlay, I would say, at different manufacturers, you always get, I would say, nearly the same PCB with the nearly same bending behavior. Yeah? The Flexmasks have more differences in their bending behavior. So what is a disadvantage of the Coverlay? As you already have heard, we have a lot of manual processes. So depending on the sizes of these Coverlay sheets, so the costs are much higher, and we have a little bit less position accuracy. So tips and tricks, what could be done? So here a slide for using a Coverlay. So using arrays, so less workload and better registration. So if you could do it by defining maybe the delivery planning, look for that all the flexible areas are in one row, that I could connect them by the Coverlay. So I have a lot of less, I would say, manual load. Or one more slide. So you could see here that I don't have the chance to connect by Coverlay because the distance here is much too small to get a Coverlay through. So make a bigger distance here, maybe of 4 millimeters, so I could connect the several Coverlays and also have less workload. And also, if I connect more Coverlays, I have a easier and better registration of the Coverlay on the Flex layer. One more thing is regarding the isolation. So you could see here on this slide, I have now the flex or the conductors on the inner layer of the bending radius, and here this is the base polyamide foil, so where the cover is on it. So if you need an isolation to the outside, so you could also turn the PCB that the flex not goes from the top layer here outside, so it goes from the bottom layer outside, and I then have the isolation also to the housing biopolyamide. or maybe with a lift-off area, like in this slide, that the bending already begins a little bit prior to the end of the rigid part, so that the flex area don't protrude out of this, I would say, of this rigid parts. Could also be a solution, this lift-off, to maybe to avoid the coverlay and to using a flexible solder mask with less costs at the end. Something about a little bit for you for later on that you could have a look at. We have a brand new design guide for our flex solutions. So it's got this week new on our homepage. So new contents, combination HDI, signal integrity, and there we also included now the comparison of flexible solder mask versus Coverlay, and also the Coverlay as an insulation foil. So you could see here, so the comparison itself in one slide. Here are the different pictures with Flexmask, Coverlay, and also we have a part inside where we speak about, or where I could read about Coverlay also as an insulation foil, yeah, for protecting in the electric strength at the end. Okay, at the end we come to the summary. We have a design guide with advantages and disadvantages. You have heard there are technical things and also commercial things. So whether you have the decision Flexmask or Coverlay, if you don't describe anything for the outer layers, we are using a flexible solder mask. If you have the decision done for Flexmask or Coverlay, the design parameters are for each technology a little bit different. So if you have the flex outer layer, flex inner layer, there are different design parameters for vias, S&D pads to the flex rigid intersection, depending on using Flexmask or using a cover foil.